We're going to have a quick lecture on the rock cycle. In the online textbook, the rock cycle comes pretty early in the literature, so I think it's important to talk about the rock cycle after we've introduced all the different types of rocks. So what is the rock cycle? So some of the things that we're going to learn about in this lecture are that rocks don't last forever because the Earth is dynamic, it's ever changing. The phenomena such as weathering, burial, heat, melting, all of that can affect a rock after it has been formed. And components of a given rock may become incorporated into other rocks or even other rock classes over time in a progression of change. Pathways through the rock cycle can reflect different geological settings and can be interpreted through the context of plate tectonics. And steps of the rock cycle can happen at different rates. So let's take a look at the rock cycle. This is essentially it. And the cycle is basically the path that a rock can take in transforming from one type of rock to another. So when we have the forming of magma can crystallize into an igneous rock. And then an igneous rock can undergo weathering and erosion, and then ultimately be deposited, or it goes through weathering and erosion into sediments, and then that goes through compaction and cementation to turn into a sedimentary rock. As heat and pressure is applied to a sedimentary rock, it turns into a metamorphic rock, and so on and so forth. A metamorphic rock can undergo melting and create the cycle all over again. We can circumvent this part of the process here when an igneous rock undergoes heat and pressure, turns into a metamorphic rock. A metamorphic rock can be eroded away, and it can form sediments and then undergo compaction and cementation and turn into a sedimentary rock, and so on and so forth. This is the rock cycle. It's the cycle in which rocks change over time. So I just gave an example of that. So let's look at it through step by step again. We have an igneous rock that's formed through the solidification of lava, undergoes weathering, erosion, deposition. Then that turns into a sedimentary rock through compaction and cementation. Through heat, pressure, and burial, it turns into a metamorphic rock. And as the rock gets heated to extreme pressures and undergoes partial melting, then it can be formed back into magma and then back into an igneous rock. Okay, let's look at one more example again. What about an igneous to a sedimentary to a metamorphic back to sedimentary? So we have, again, the igneous rock undergoes weathering, erosion, deposition, undergoes compaction, cementation into a sedimentary rock, undergoes heat and pressure to a metamorphic rock, and then that metamorphic rock gets eroded away through weathering, deposition, turns into sediments, gets compacted and cemented back into a sedimentary rock. It's a very simple process, and this is the way we can describe it. So let's take a quick YouTube video look at this.
Okay, let's take a quick look at the rock cycle. Here's a diagram showing the rock cycle in the Earth's crust. This particular diagram can be found in the New York State Earth Science reference tables. What it shows are the different types of rocks and how they can change over time. Let's go through a quick example. Here is a chunk of an igneous rock known as granite. You can see it's made up of intergrown crystals of potassium feldspar and quartz and biotite, and that's what gives it its speckled look. Now, as we mentioned, granite's an igneous rock, which forms from the solidification of melted material, magma or lava. Granite happens to form deep underground from the slow cooling of magma. But the question we want to look at now is, well, what can happen to this igneous rock over time? And there's a handful of possibilities. The first thing that could happen is our granite could be lifted up, forced up from beneath the ground, where it's exposed to weathering and erosion. The wind, the rain, the ice, these forces break this rock down into little small pieces called sediments. So now our granite has been broken into small pieces of granite. Now these little small sediments can be deposited and buried, and then compacted and cemented together to form a brand new rock called a sedimentary rock, like this piece of sandstone. So simply by weathering and eroding the granite into sediments and then squeezing the sediments back together, you've converted your igneous rock into a sedimentary rock. But that's not the only thing that can happen to our igneous rock. What if it is pushed even deeper underground by the movement of Earth's tectonic plates? And in so, it is exposed to intense heat and or pressure, causing it to metamorphose or recrystallize into a metamorphic rock, like this piece of gneiss seen here. So, with the simple addition of some heat and pressure, we've turned our igneous rock into a metamorphic rock. But there's still one more option. What if our igneous rock is exposed to intense heat, causing it to melt and return into liquid state of magma? Well, it can then, of course, cool and solidify again, giving us another igneous rock. But maybe this time it will cool quickly and give us something with smaller crystals or maybe no crystals at all, like this piece of obsidian. So what you can see is that on the rock cycle, any rock is able to turn into any other rock when exposed to the different processes in and on the Earth's surface. Remember, we start with these three types of rocks. These are our three classifications. And from them, we can go to anything else. Again, let's look at the igneous rock, right? Igneous rock, we know, forms from melting into magma and solidification. But remember, it can melt again, and that process can happen over and over and over again. So I can have an igneous rock that becomes igneous again, maybe a different kind of igneous rock. But any rock can melt into magma and form an igneous rock, as seen on the chart. Sedimentary, metamorphic rocks, they can all be melted and ultimately result in an igneous rock forming. Well, let's look at the sedimentary rock. Now remember, these form from sediments that have been deposited and buried, and pressure causing them to compact and cement together. But of course, any rock can be weathered into sediments, and therefore any metamorphic or igneous rock can become a sedimentary rock. Finally, we have our metamorphic rock, and remember, these form when rocks are exposed to intense heat and pressure. But of course, that process can take place with any type of rock, sedimentary, igneous, or even metamorphic rocks. So the key idea behind the rock cycle is the fact that any rock can become any other kind of rock. It can even become itself. Change is always taking place. It's generally slow over many millions of years. However, the results can be impressive. Thanks.
Of course, rock cycles, sedimentary rocks, igneous rocks, metamorphic rocks, they all have to do with plate tectonics. Plate tectonics are the building block, the bread and butter of earth sciences. So how do they relate? Well, as magma reaches the Earth's surface, they can create a hotspot or a volcano that creates magma that then turns into basalt, for example. That's how we get igneous rocks. Once that rock is at the surface, then that basalt can interact with the wind and rain and erodes away, and then it gets flaked into clays. It gets transported down a river stream. And as those deposits accumulate at the shelf or passive margin, that's when a sedimentary rock can form. Now we have the sedimentary rock that undergoes burial and subduction as the two continents collide. And this is where we undergo metamorphism. So there's an example of the rock cycle in a convergent plate setting. Here's another example of, so if we have rocks that are plates that are moving together, we have a mountain belt uplift. So this is where we have shale that was once exposed, now undergoes extreme heat and pressure, undergoes metamorphosis at this plate boundary, and now it creates schist. So here's another example of, again, convergent plates coming together. We have a rock that has undergone metamorphism and due to plate tectonics. Oh, my image is in the way. So another example here is once we have those rocks that are created through the plate boundary, they eventually can get uplifted through that mountain belt, and then we have surface processes through erosion that can erode those sediments and then deposit them somewhere else. Okay, so now in a divergent plate setting, imagine that the plate boundary changes now as in a rift zone so that the plates are now being pulled apart. So here we have hot magma that rises and heats the crust. And then right here we would have igneous rocks, but right around it we would have contact metamorphic rocks. And this partially melts and we have new felsic magma that forms things like rhyolite and that new igneous rock. And of course, as this reaches the surface, here is where we would have sedimentary rocks being deposited as a result of igneous rocks being eroded away and things like that. Okay, so just really quickly, the Earth is really dynamic. We have changes that occur all the time. We have internal heat and the convection that drive plate movement, which ultimately is a driver towards having this rock cycle. We have plate interactions that cause these different formation of rocks, like igneous rocks, for example, through divergent plate boundaries where they're formed. And of course, we have surface systems that cause weathering and erosion, ultimately sedimentary rocks. So the things that we covered is that the rocks don't last forever because the Earth is dynamic. We have phenomena like weathering, burial, and heating that can affect the rock after it has already been formed. Components of rock may be incorporated into others and change the class of a rock over time. Pathways for rock cycle reflect different geologic settings, and they can be interpreted through the context of plate tectonics. And the rock cycle can happen at different rates. So I didn't talk too much about that, but in a plate tectonic setting, plates move very, very slowly. And so that can take thousands to millions of years to occur. We can also have surface things like the transformation of sediment from a river that's being deposited with overburden. That can only take a few hundred years. So in the scheme of things, the rock cycle can take place over long periods of time due to plate tectonics, or even short periods of time, like through a volcano, and how quickly those igneous rocks can be created. So different speeds, different rates for the rock cycle. That's it.